Good day, everyone. So we'll continue our discussion in our subject, solid mensuration. So our topic for today is all about quadrilaterals. So we all know that quadrilaterals are four-sided polygon. So what are quadrilaterals? Quadrilateral, also known as tetragon or quadrangle, is a general term for a four-sided polygon. So there are six types of quadrilaterals. So there are the square, parallelogram, rectangle, rhombus, trapezoid, and trapezium. Each type of quadrilateral has unique properties that make it distinct from each type. Square is the most unique quadrilateral because it possesses all those unique properties. So probably those are equal length of sides and probably equal angles, which forms 90 degrees. So common parts of a quadrilateral. So the following are the side, which is a line segment which joins two adjacent vertices. The interior angle, which is angle formed between those two adjacent sides. The height or altitude is the distance between two parallel sides of a quadrilateral. Base is the side that is perpendicular to the altitude, and the diagonal is the line segment joining any two non-adjacent vertices. So classifications of quadrilaterals, we have parallelogram, trapezoid, trapezium, and under parallelogram, you have rectangle, rhombus, and square. So parallelogram has two pairs of parallel sides. Then trapezoid, which has only one pair of parallel sides, and trapezium does not have any pair of parallel sides. And the special types of parallelograms are rectangle, rhombus, and square. So general formula for the area of quadrilaterals shown in this given figure. You have your diagonal 1 and diagonal 2, which is represented as E1 and E2. For this particular figure, you have your vertices, and those capital letters indicates the angle, okay? And sides are provided in small letter. Theta here is the angle between the two diagonals. So you may need to uh, familiarize yourself with these given formulas. Okay, so for the area for this particular given, if you are given as the diagonals, okay, and the angle formed between the diagonals, you have this formula where it is stated as 1/2 the product of diagonal 1 and diagonal 2 multiplied by sine theta. And formula 2, you have 1/4. Okay, so there's a correction here. It should be E1, right, multiplied by E2. Okay, so E1 and E2. So you take note of that. So 1/2 diagonal 1 and diagonal 2 or E2. And for formula 2, you have this formula given four sides where you should be familiar with these labels such that the square, okay, the sum of the squares of the opposite sides must be greater than the square of the other sum of the other two sides. Okay, you have this formula 1/4, right? And then the sum of the square of the two opposite sides minus the uh, sum of the sum of the square of the other two sides, and that is the absolute value of the tangent theta. Then you have formula 3 where sides are given and also the angles are any two opposite angles of the quadrilateral. It can be uh, A or C or B and D. Okay, so you can use this one, and you're familiar with S, which is semi-perimeter. Okay, So you have this formula, square root of the product of semi-perimeters, minus side A, side B, side C, side C minus the product, then the square of the cosine of the half, uh, the sum of the angle of any two opposite sides. Okay, so in formula 1 and 2, sine theta can also be this value, and tangent theta can also be this value. Thus, you can choose other angle formed by the two diagonals without affecting the area of the quadrilateral. Some problems about quadrilaterals. So problem 1. A vacant lot has the shape of a trapezium with sides 8 meters, 12 meters, 18 meters, and 20 meters. So if the sum of the opposite angles is 230 degrees, find the area of the lot. So you have the sum of the two opposite angles and the sides of the quadrilateral or trapezium. So based on the given, you can draw the given figure, okay, based on the given sides. Okay, you approximate those length and connect each of the vertices. So I have provided a given figure shown here. So the sum of the two opposite sides is, or two opposite angles is 230 degrees. So theta 1 and theta 2. I indicated the two opposite angles as theta 1 and theta 2. Then the sides are 8, 12, 18, and 20 meters, I mean. Okay. So the required is the area of the lot. So solution, how are you going to approach this problem? Okay, so based on the given, you have the sum of two opposite angles, which is 230 degrees. Okay, so we can solve for theta 1 plus theta 2 all over 2, which is equivalent to 230 degrees all over 2. And that gives us a 115 degrees for that particular value. Then we can now solve for the semi-perimeter since all of the sides of the quadrilateral are given using the formula. Okay, so sum of all sides is the perimeter and you divide that by 2. Okay, so you substitute all the given values, which are 12, 8, 18, and 20, and divide it by 2, you'll arrive to an answer of 29 meters. And solving for the area, you can use formula 3. Okay, so the third formula under quadrilateral have this formula. Now we substitute the given values. S as 29, then A, B, C, and D are sides of the trapezium or quadrilateral. Then the product of A, B, C, and D, the square of cosine, and our angle. Okay, this one, 115 degrees. Substituting those values, we'll have this equation. And simplifying that using your scientific calculator, you have an area of 170.80 square meters. Let's try another one. So quadrilateral contains two equal sides measuring 12 centimeters each and an included angle, okay, which is a right angle. And then if the measure of the third side is 8 centimeter and the angle opposite the right angle is 120 degrees, find the measure of the fourth side of the area of the quadrilateral. You have this given. Based on the given, there are the measurements of the sides are 12 centimeters. Okay, so there are two sides which are equal, and then an included right angle. So therefore, these are the two adjacent sides. Okay, and then uh, you have the third angle, which is 8 centimeter, and the angle opposite the right angle is 120. So I have this given figure. You have the two sides, which measures 12 centimeters, and the included angle between them is 90 degrees. And one side is 8 centimeters, and the angle opposite the 90 degrees is 120. So find the fourth side. So I have indicated the fourth side as unknown as x, okay, and also determine for the area. So the fourth side and the area are the required. So fourth side is designated as x and the area is unknown. Simple solution, okay. So I'll just draw a diagonal line, okay, and you get two possible triangles, which is a right triangle and an obtuse triangle. Is separating those triangles, and I'll just provide the diagonal itself as y, or the unknown value. Okay, so I'll just first consider the right triangle, okay, and I'm going to solve for the hypotenuse, which is the diagonal here. Okay, so referring to that using the Pythagorean theorem, given two sides, okay, or you can use the uh, a trigonometric function, which is a tangent function, or probably sine function or cosine function, because this is since this is a right triangle with equal sides, so probably the angle here is 45 degrees. So I'll just use the Pythagorean theorem, which is the square of the hypotenuse is equivalent to the sum of the squares of the other two sides. So A and B are 12 and 12, and the hypotenuse side is y based on this right triangle. Okay, so substituting those values, you have your hypotenuse as y equals the square root of the sum of the squares of the other two sides. So 12 and 12. Then simplifying that, you get answer for the diagonal y, which is 12 square root of 2 centimeters. Now moving forward, okay, so since we have a value of 12 square root of 2 centimeters, I can also have this value as 12 square root of 2. Now I will consider this triangle now. Okay, so I just consider the obtuse triangle and solve for x. So for that, we need to determine the angles probably. Okay, then before we can solve for x, we need to solve for the unknown angles of the triangle using the law of sines. So law of sines states that this equation. So that is, you can use this by pair, like for example, a all over sine a equals to b all over sine b, those two only, or b sine b and then c sine c, those two, or a sine a and then c sine a. So you can use law of sines by pair. Okay. So continuation, we now have this value, okay, 12 square root of 2 centimeters for the diagonal y, and then solving for angle A, probably this one, okay, using law of sines. Okay, so just use A all over sine A, that is equivalent to B all over sine B. So I just substitute those values. I just arrive to 8, which is this one, and then all over sine A, which is this angle here, the opposite of this side. Okay, and then will be equal to the given, which is this is one of the given, which is 12 square root of 2 all over sine of the opposite angle, which is 120. Simplifying that one, we will arrive to these values. So that gives us arc sine of uh, 8 sine 120 all over 12 square root of 2. Then the angle is 24.09 degrees. Take note that this angle is angle A on this obtuse triangle. Now, recall that the sum of the interior angle of a triangle, or any triangle, is equivalent to 180 degrees. Now I can solve for the unknown angle B here. That gives me 35.91 degrees. Okay. So continuing, since we have the diagonal y here, okay, you have the angle, okay, all of the interior angles are provided. Simply I can solve for x. Similarly, you can use law of sine, or you can use law of cosines. Okay, so you should be familiar with those when dealing with obtuse triangle. So probably I'll just use law of sine, which is x is the unknown side, okay, which is this one, all over sine, which is the opposite angle, which is b, 35.91, will be equal to 8 all over sine 24, which is 8 all over sine 24 degrees is opposite. Okay, then simplifying that one, could arrive to this equation, 8 sine 35.91 all over sine 24.09 degrees. Then using your calculator, the value of the fourth side is 11.5 centimeters. So the port side is 11.49. Actually, that is 11.49. So I just approximate that value to 11.5. Now, continuation, we need to determine for the area. Okay. So referring to the given figure to the left, this one. Okay. So we now have 11.5. So all sides are given. Okay. And then two opposite, okay, angles are given. So I could use probably formula number 3. Okay, so I could solve for the uh, sum of the opposite angles divided by 2. So that gives me 105 degrees using the formula for the area given 3 sides and 2 opposite angles. Okay, we can use that value, okay, in order to solve for the area. We need to first determine the semi-perimeter. Okay, so you are familiar with this formula. Substituting the value of those sides, you'll arrive to a semi-perimeter of 21.75. And then using the formula, okay, so that is S minus A, S minus B, C, and D, then product of A, B, C, D, cosine of this one. We have the angle, the sides, and then substitute those values to this formula. Substituting it, you'll arrive to this equation and simplifying that one. Okay, so 21.75 is S, then A probably is 8, okay, and then S minus B, so 2175 minus 12, 2175 minus 12, and then 2175 minus 11.5. You could use 11.49 if you want to. Okay, then minus the product of all the sides, 8, 12, 12, and 11.5. Then cosine squared, the angle is 105 degrees. So final answer will be 111.85 square centimeters. So that is the area. So the final answers are 11.49 or 11.5 centimeters and 111.85 square centimeters. So let's talk about parallelogram. Okay. So parallelogram, you can say a figure given here. Okay, so you have the base, altitude or the height that is perpendicular to the base. Can also be included here from this corner, then draw a perpendicular line that is 90 degrees here. That could be altitude. Okay, so you have here two diagonals probably. You have the longer diagonal and shorter diagonal. Okay, so definition of parallelogram is a quadrilateral in which the opposite sides are parallel. So opposite sides, so probably AD and BC are parallel to each other, and similarly A and B or side AB and CD are parallel to each other. Okay? And then the parallelograms have the following important properties. Opposite sides are equal, AD, BC, right? They are equal in length, and DC or CD and AB are also equal. Opposite interior angles are congruent. So example of which is angle A and angle C. They are equal in value. Similarly with angle B and angle D. Okay? Adjacent angles are supplementary. Okay, so adjacent angles which are uh, A and D, D, probably, right? And similarly with A and B, right? B and C, and CD, right, are equal to 180 degrees. Then a diagonal divides a parallelogram into two congruent triangles. So probably ACD, triangle ACD, is congruent to triangle ACB, right? Or DAB, which is similar, DAB, and DCB, this one. Either which they are congruent triangles. And the two diagonals bisect each other. Okay? Diagonals of a parallelogram. So probably if sides AB and the theta are given, then by cosine law, you'll arrive to this formula. Right? So probably theta is the one that is opposite to the diagonal. Okay? So if I have a diagonal here, probably the angle is one of the corner. Okay? Depends on the diagonal, but this is the formula. Okay, so for example, this one. You have a diagonal here. Okay, so I'm referring to if this is the unknown or required, which is the diagonal, by cosine law, theta should be opposite. Okay, or similarly, if the angle is right here, you can use that one because angle B and angle D are congruent or equal in value. Similarly, if you have a diagonal here, okay, from D to B or B to D, the opposite angle should be at angle C or angle A. Okay, so you have the altitude, and based on that, you can draw the altitude here, and you can create a right triangle here. Okay, if any two parts of a parallelogram are given, the relationship among A, which is a side, height, and theta may be obtained from the right triangle. Okay, using the other angle, which is 180 and theta, the second diagonal may be obtained for the same formula, right? Using that one. What I'm referring to 180 degrees minus theta. Okay, so this is theta, that is also equal to theta. Then by supplementary angle, okay, you can solve for this value. 180 degrees minus this value, you'll get this angle here, interior angle C. So the perimeter and area of a parallelogram. So you have up for the perimeter, you have opposite sides of a parallelogram are equal. So you could say that uh, A plus B and plus B, right? You get this simple equation. So the perimeter is equivalent to twice the length of A and uh, twice the length of B. Okay, and then you have the area for the parallelogram. You have two formula here. So you have the, if given base and height, you can use this formula. Then you can use this formula for if the given two adjacent sides and an included angle between them, okay, is given, okay, or any interior angle probably can be used. So take note of those formula. Okay, you might be using them in the future lessons. Some illustrative problems for a parallelogram. So problem 3. Find the height of a parallelogram with sides 10 and 20 inches long and an included angle of 35 degrees. Also calculate the area of the given figure. So based on the problem, we need to determine for the height and also the area of the parallelogram. And we have given sides of 10 and 20 and the included angle between them. So based on those given, you can draw a similar figure. Based on those given, you may need to approximate those length and angle. Okay, so I have provided a given figure. Okay, you have this given with two sides and an included angle between them, which is 35 degrees. So the two sides are 10 and 20 inches long. And I have provided you here, I draw a perpendicular line from this uh, vertex, okay, to determine for the height of the given figure or parallelogram. So we all know that the height or altitude is perpendicular to the base, okay? So the required are the height, and the area. So for the solution, based on the given figure or parallelogram, I can get a triangle. Okay, so you have side 20, 35 degrees, and the altitude. Okay? Solving for the height using the right triangle that can be drawn from the given figure. Okay, so I have this given figure. I could use now probably I cannot use Pythagorean theorem because two sides are not given. Okay, I have three sides here, which is two sides are unknown. I might use call this trigonometric function. Okay. So probably based on the given, the angle, and then that is the opposite side and the hypotenuse. So probably I'll use sine function. So sine 35 degrees is equivalent to the opposite side, which is height, all over the hypotenuse, which is 20. Simplifying that, have this equation, so the height is 20 multiplied by the sine of 35 degrees, and the height is 11.47. Now, solving for the area of the parallelogram, right? So based on the given figure, I have here two sides and included angles. So I may use one of the formula, which is AB. So area is equivalent to the product of the two sides and then sine of the included angle. Okay, so this formula, A is 10 probably and B is 20. So substituting those values with 35 degrees as theta, you'll get an answer of 14.72 square inches. So probably the answers for this problem is 11.47 and 114.72 square inches. So next problem. So a certain city block is in the form of a parallelogram. So the given is a parallelogram. Two of its sides measures 32 feet and 41 feet. Okay, if the area of the land is in the block is 656 square feet, what is the length of its longer diagonal? So the unknown is the longer diagonal, length of the longer diagonal. Based on the given, you are given two sides and the area of the lat itself. Okay, so based on the given provided here, okay, so the uh, length of the measurement of the block is 32 and 41, and then an area of 656 square feet. We need to determine the longer diagonal. So based on this given, so probably this is the shorter diagonal and probably this one is the longer diagonal. So we need to determine the length of this diagonal here. Okay, so the required is the length of the diagonal. So based on the solution, let me use this figure. Okay, so solving for the theta. Okay, using the formula for area. Based on the given, you are given area, you are given two sides, and then the included angle is unknown. So I can use this formula to solve for that unknown value. Substituting them, so 656 square feet, then sides AB, then sine. So dividing both sides by 32 and 41, and taking the arc sine for the in order for you to solve for theta. So simplifying that one, get an answer of 30 degrees. So probably theta here is 30 degrees. And moving forward to solve for the diagonal, so I have used the original given figure, 32, theta, and 41. So theta here is 30 degrees. And then probably the exterior angle here is 30 degrees also. Now, in solving for the longer diagonal is connected from this vertex up to that vertex. Okay, so giving this figure, and two parallel sides are equal based on the properties of a parallelogram. Similarly, the base is equal to the upper part. Right? So now, since we are solving for this diagonal, we need to determine the opposite angle of that diagonal, which is beta. Okay, so since this is theta, which is 30 degrees, and this full angle here, which is equivalent to 180 degrees. Solving for beta, okay, so 180 degrees minus 30, that gives us 150 degrees. Now, solving for the diagonal using the formula for the diagonal of parallelogram. This is derived from the law of cosines. Okay, so diagonal is this one, unknown. Okay, and then the opposite angle is beta. So this one is beta, and then A is probably 32, B is 41, the 2AB cosine theta. A theta now it will be 150. Okay, substituting those values, but before that we need to square root both sides and then substitute the given values. You get an answer, substituting those values you get 32, 41 for B, then 2 A and B, which is 32 and 41, and then cosine beta. Okay, so 150 degrees. And then simplifying that using your calculator, the length of the longer diagonal is 70.55 feet. So now we'll be dealing with the kinds of parallelogram. So probably these are the square, rectangle, rhombus, trapezoid, and yes, probably later on trapezoid. So okay, so probably let's talk about first rectangle. So you all know the figure. This is a rectangle. Okay, so two opposite sides are equal, probably, and then there are two equal diagonals here. Okay, and then all of its angles are 90 degrees. Okay, so interior angles are equal to 90 degrees each. Okay. So rectangle is essentially a parallelogram, okay, because of its definition, parallel sides. Okay, and interior angles are all right angles. So since a rectangle is a parallelogram, all of the properties of a parallelogram also hold for a rectangle. So in addition, the diagonals of the rectangle are equal. Okay, so however, sides are not necessarily equal. Okay, then you have the formula for the diagonal, which is cuts the rectangle into two congruent triangles like triangle ABC, okay, and equals to triangle ABC. Similarly with BDC and ABD. Okay. So you have this formula. So the square of the base plus square of the height. So this is derived from a Pythagorean theorem, probably referring to a triangle, right triangle. So perimeter of a rectangle. So similar formula for the parallelogram that gives us twice the base. Okay, because this side is equal to this side. So that is b plus b, that gives us 2b, and height or age is equal to this value here. So 2h, so h plus h, that gives us 2h. So twice the base plus twice the height. So area of a rectangle is simply derived from a two rectangles or triangles, I mean. Formula for the triangle is 1/2 base multiplied by height, and you multiply by that formula by 2. So that gives us base multiplied by height for a rectangle. Now for the square, all sides are equal. Okay, so definitely diagonal are equal. Okay, and then this is side A, all of its sides are A in value, diagonal, and all of their angles are 90 degrees. And if you're going to get this triangle, right, so since this is a right triangle, the angle here now is 45 degrees, and similarly to this one. Now, square is a special type of rectangle in which all sides are equal. Since all sides and interior angles are equal, a square is classified as a regular polygon of four sides. So the diagonal of the square is derived from a Pythagorean theorem, so referring to this side, solving for the hypotenuse. Okay, so we arrive to this equation. Then the perimeter of the square, so a plus a plus a plus a, so that gives us 4a, 4 times side a. And the area of the square is similarly base multiplied by height. That can be, this can be the base and this can be the height. So substituting the value a multiplied by a, that gives us a squared. Okay. For rhombus, okay, so probably all sides are equal. Okay, you have two diagonals, okay, shorter diagonal and longer diagonal. Okay. Then if this is angle theta, this is also angle theta. Okay. Similarly, it bisects the diagonal to two equal parts. So for the diagonal is drawn here, similarly a diagonal drawn is here. They have, this is D2 and this is D2, I mean this is the whole diagonal. So it divides that to two, okay, congruent segments. So D2 all over 2, this is the value of this segment here. Similarly, this is D2 all over 2. This is D1 all over 2, and this is D1 all over 2. Okay, so a rhombus is a parallelogram in which all sides are equal. Okay, may be defined as equilateral parallelogram. Okay, so the rhomb and diamond are sometimes used instead of rhombus. So rhombus can be also called as rhomb and diamond. So a rhombus with an interior angle of 45 is sometimes called lozenge. Okay, so take notes of those terms. Then the diagonal of the rhombus, okay, can be solved using this formula here. Okay, so that is the, they call this, derived from law of cosine. Okay. And similarly, if the diagonals are given, you can solve for the unknown side. Okay, so if the diagonals are given, you can solve for the side by means of Pythagorean theorem. So since this is right triangle, so all of them are right triangles. So this one probably. Okay. So by Pythagorean theorem, since this is 90 degrees, opposite of that is a hypotenuse. So the longest side. Okay, so you may need to memorize those formulas here. Okay. So diagonal 1, diagonal 2, probably shorter diagonal and longer diagonal. Then the angle for the opposite, okay, of shorter, opposite the shorter diagonal, which is D1, okay, is theta. Okay, so you need this formula if given the diagonals of the rhombus. Similarly, you have the height, then base, so the area for this can be written as base multiplied by height, okay, or b squared sine theta. Okay. So the perimeter is given as the sum of all sides. So all sides are equal for a rhombus. Okay, so sides B. So there are four B's here, or four sides, so 4B. So area of a rhombus can be used as this formula. If given the two diagonals, okay, you can use this formula, 1/2 diagonal 1 multiplied by diagonal 2. And then the area can also be used if given as base and height. You can use this formula, and you can use if two sides and an included angle is given, you can use this formula. Okay, b squared, that's sine theta. Trapezoid. Based on this one, you have the bases A and B. You have the altitude, okay, and the angle probably, right? So trapezoid is a quadrilateral with one pair of parallel sides. So parallel sides are probably the bases here, so A and B. Then in a trapezoid shown above, this one, the parallel sides are A and B, called the bases, and height is the altitude, H. If non-parallel sides are congruent, the trapezoid is called isosceles trapezoid. So the base angles are also congruent. So if this is an isosceles trapezoid, base angle here, similarly here, they are congruent. And a trapezoid which contains two right angles are called right trapezoid, as shown in this given figure. Have two bases, A and B, altitude, and one uh, included angle, which is theta probably. So area of the trapezoid, you can use this formula. Okay? So the mean of the bases multiplied by the height. So that is 1/2 a plus b, or the bases, sum of the bases, multiplied by height. And a trapezium is a quadrilateral with no parallel sides. Okay, so in finding the area of a trapezium, you can use the three formulas for the quadrilateral from our early discussion of quadrilateral. So the three formulas given there. Some illustrative problems. Hey, problem 5. The diagonal of a rectangle is 25 meters. Okay, and makes an angle of 36 degrees with one side of the rectangle. So find the area of the perimeter of the parallelogram. So based on the given, you have the diagonal and an included or an angle that makes with one of the side of the rectangle. So those are the given, and you need to determine the area and the perimeter of the parallelogram. So this is a rectangle and that is under a parallelogram. Okay. So based on the given, you have here the diagonal. The length of the diagonal is 25 meters, and then one of the bases, right? So one of the side. So based on this one, which among those two interior angle of a rectangle is greater? So probably this side. Okay, so probably I'll just putting 36 degrees here. Similarly, if you're going to indicate 36 degrees here, you can also do that. Okay? And the required are the area and the perimeter. So solution, probably we need to determine first the sides of the uh, rectangle. Okay, so I may want to use a right triangle here. So probably this triangle here, okay, the right triangle. So you have 25 as your diagonal, angle of 36 degrees. So probably I'll just place base and the height as shown here. Okay, so solving for side B, this one, I only have one side given and an angle. I can use a trigonometric function. So probably a cosine function. Cosine is equivalent to adjacent and a hypotenuse. So cosine 36 degrees is equivalent to adjacent side, which is b, all over hypotenuse. Simplifying that one, I could get this equation, and using your calculator, the side b is equivalent to 20.23 meters. Okay, and similarly, solving for the height, this one, I could use a sine function. Sine of an angle is opposite, okay, and then all over hypotenuse. So sine 36 is equivalent to opposite all over hypotenuse side. And simplifying that one, you could arrive to this equation, 25 sine 36, and then using your calculator, the height is 14.69 meters. Now, since the sides are given, okay, let us determine the area. So formula for area is base and height. So base and height are given. Okay, so substituting those values and then using your calculator, you have an area of 297.18 square meters. And solving for the perimeter, okay, so the formula for the perimeter is twice the base plus twice the height. So this formula, substituting the value of base and the height, that gives us this equation, and using your calculator, you'll get 69.84 meters. Next problem. So find the area and perimeter of a square, okay, whose diagonal is 15 centimeters long. So the given is a square. All sides are equal. and also the diagonal. So we need to determine the area and perimeter. So based on the given square figure, diagonal of 15 and sides are unknown. Okay, so required is the area and perimeter. So solving that one, you can use a right triangle based on this given figure. Okay, so that gives us a 45-degree angle here. Okay, so take note of that. So whenever you draw a diagonal and take up a right triangle from a square, the angle is always 45 degrees. Okay, then using what you call this, I could only solve one side because all sides are equal. Okay, so I could solve for side A, either which I could use cosine or sine function. Okay, so solving for side A, I'll be using cosine, which is adjacent all over hypotenuse 15. Right? So adjacent side is this one. Okay, that is right next to the given angle. And when you say opposite, right, that is away, right, from that angle. So cosine is adjacent, which is this one, all over the hypotenuse, which is 15. Simplifying that one, you get this equation, 15 cosine 45 degrees, and that gives us 10.61 centimeters. So all sides are now known. Now solving for the area, right? So area is a squared, right? So base, if this is the base and this is the height, b multiplied by h, so that gives us a and a, so a squared, right? Substituting the values 10.61, and you'll get an answer of 112.57 square centimeters. And now solving for the perimeter. So the perimeter is sum of all sides. So A plus A plus A plus A. So probably that gives us 4A. So perimeter is equivalent to 4A. And substituting the length of one side, which is 10.61. 4 times 10.61, that gives us 42.44 centimeters for the perimeter. Okay, next problem is the area of a rhombus is 143 square meters. So this time it is a rhombus. So if the longer diagonal, take note of that, longer diagonal is 26 meters, find the angle opposite the shorter diagonal and the length of one side of the rhombus. So by definition, a rhombus has equal sides. Okay, so all sides are equal, so we need to determine the length of one side, and then also we need to find the angle opposite the shorter diagonal given our longer diagonal and the area of the rhombus. Okay, based on the given, I'll just draw a given figure. Okay, so based on the rhombus, sides are equal, and then the diagonal is 26, and also the area is 143 square meters, and the required is the angle, okay, and the length of one side. Okay, so based on the solution, how are you going to approach this one? So based on the given, you are given an area. Okay, so probably you can solve for what? Huh, a diagonal. Okay, so we can solve for the diagonal, shorter diagonal here on this side or on these vertices. So this one is the longer diagonal, this one is the shorter diagonal, using the formula of 1/2 diagonal 1 and diagonal 2. So substituting the value of area and the diagonal 2, probably this one is the longer. Okay? So diagonal 2 is longer, diagonal 1 is shorter. Simplifying that one to solve for d1, you get this equation. And using your calculator, 2 times 143 divided by 26, you'll get the shorter diagonal as 11 meters. Okay, from this given. Now, based on the given, I have solved for the diagonal one, which is the shorter. Okay, I have the sides and then an angle. Okay, so solving for the angle of the shorter diagonal, right, you can use this formula. It is stated in the discussion earlier. So that is twice the arctan of the ratio of the shorter and longer diagonal. So substituting the values, shorter is 11, D2 is longer, which is 26. Using your calculator, theta is 45.86 degrees. This one. So that is the angle for the shorter diagonal. Okay. Now, you need to solve for the what you call this length of one side. Okay. Now, solving for side B. Okay. Since solving for side B, I could use uh, formula for probably given two diagonals, okay, by means of Pythagorean theorem. It is also included in the lecture earlier, so that gives us probably this one. Okay, so that is the formula for area since it is given. Okay, so area and then the square of the side sine theta. Then simplifying that one, okay, to solve for b or the side, you have arrived to this equation. Then substituting the given values, you'll get side b as 14.12 meters. So the length of one side is 14.12 and the angle opposite the shorter is 45.86. Okay, problem last problem probably. Okay. So trapezoid has an area of 144 square meter. So the area of trapezoid is given and an altitude of 4 meters. Its two bases have a ratio of 4:5. What are the lengths of the bases in terms of meters? Okay, so the area is given. It is a trapezoid. Altitude is 4 meters. And then the ratio of the two bases is 4:5. So the given are a trapezoid with a height of 4 meters. Okay, and then two bases parallel to each other. Okay, A and B, which are unknown. Okay, and then the ratio of their bases is given as 4:5, which is A all over B is equal to 4:5, and then the area is 144 square meters. So this the unknown is the length of the bases, which is A and B. Those are the unknown or the required. Solving this one, okay, based on the given, okay, from the ratio of the bases, as this ratio, okay. So given that one, I can solve for probably A, side A. Okay, multiplying both sides by b, so the value of a is 4:5, 4 all over 5 b. Let us assume this is equation 1. Okay. Then, since the area is given, we can use the formula for the trapezoid. Okay, so area of the trapezoid is given as uh, mean of the bases multiplied by height, or simply 1/2, then a plus b multiplied by height, since height is given. Okay, and area is given, and also this equation. Okay, then using that formula, substituting the values 144 for the area, A and B, height is 4, then simplifying that one, I could arrive to this value. I just assume this is equation 2. Now, I have two equations, okay? I could substitute equation 1 to equation 2. So the value of A is 4 all over 5. I could substitute that here. So this becomes 4 all over 5b. Okay, so that gives us this equation. And then simplifying this one, this gives us 9 all over 5b. That is equivalent to 72. And then simplifying this one, or multiplying 5 all over 9 on both sides to determine for b. Okay, so b now is 40 meters. Okay, so I have 40 meters for b. Now, in order to solve for a, I'll substitute the value of b to equation 1. Okay, so this equation. So a now is equivalent to 4 all over 5 multiplied by b. But b is 40. So I'll use 40. Okay, so simplifying that one, side A is 32 meters. So that's all for the quadrilaterals. Hope you enjoyed this lesson. Our next topic will be arcs and circles.